Thank you for attending this presentation of our new STAF system. STAF stands for Steel Tube Air Forming. Developed by Sumitomo Heavy Industries, STAF can significantly reduce the weight of car bodies, frames, and other auto parts. The STAF system is a technique that applies heat to pipes and uses high-pressure air to simultaneously blow, mold, and quench. The concept is light, strong, simple. We can make a 1,500 megapascal class closed cross-section with a flanged continuous irregular shape, all molded in one process. We expect this breakthrough to reduce weight by around 30%. Eliminating the need for separate flange parts cuts material cost. One-step shaping also simplifies equipment arrangements. Take an A-pillar, for example. Let's see a cross-section. We have built this with a closed cross-section and a continuous irregular corner radius. To this we have welded an outer panel, so there are two parts. The ends of the flanges are a single curved sheet. This makes the material stiffer, thus enabling a thinner and lighter part. If we press sheets to make the pillar, then it will have a non-continuous closed cross-section comprising three parts because we must shape and trim the inner panel and stiffener, and then spot weld the outer panel into place. Let's compare three ways to make an A-pillar: hydroforming, hot stamping, and STAF. A hydroform pillar will have four parts because it requires flanges. Hot stamping has three parts: an inner panel, a stiffener, and an outer panel. A STAF pillar has two parts because the inner panel and stiffener form one piece. Take a look at a STAF equipment line. Here is an overhead view of a line with a straight arrangement. It is 92 feet long and 46 feet wide, covering about 4,300 square feet. First, a small press does the preforming. The pipe is then heated inside the press die and simultaneously blow molded and quenched with high-pressure air. This one-step approach cools the pipe to around 200 degrees. The molded part is sent to a laser cutter. After the shape is checked, holes are drilled and the ends cut off. Because STAF requires no trimming, we can shorten laser cutting time. Our idea is to sync the laser cutter's timing with the molded press to create a production line with one press and one laser working at the same pace. You can also arrange the equipment like this. One machine is a transfer robot to boost operating efficiency. This layout covers an area of 46 feet by 69 feet, 25% less space than the straight line arrangement. Observe the different production processes. Let's look at hot stamping first. We blank the material and heat it in a furnace. We shape and quench, then drill holes and trim. We then weld the top and bottom parts together. This is the STAF manufacturing process. We joule heat a preformed pipe in the die, inject high-pressure air, quench, then remove the material to cut off the ends and drill holes with a laser. Let's compare. STAF heats, molds, and quenches all in one step. And there's no assembly, reducing 4 of the steps to 2. So how do we use the die to create a flanged, continuous, irregular shape with a closed cross-section in just one step? We set the pipe in the press die, enable the electrodes and joule heat. After heating, we close the die, We supply high-pressure air and shape the flanges. We again inject high-pressure air to press the pipe along the inner surface of the die, thus producing a flanged, continuous, irregular shape with a closed cross-section. Take a look at a cross-section. We set the pipe and heat it at 900 degrees for 10 seconds. The die is half open when we supply high-pressure air and inflate the flange sections. At the same time, we close the die to shape the pipe. Then, in order to properly quench the corner radius sections, we again supply high-pressure air to press the pipe against the die while simultaneously quenching. We remove the piece after cooling for 20 seconds. Staff is special because you can shape flanges at the same time, the ends of the flanges are connected, and you get a continuous closed cross-section. Staff material is just as hard as hat stamping material, or better, and reduces spot welding points. Using staff parts in an automobile improves the torsional stiffness of the frame. You can also manufacture a frame with equal torsional stiffness, only thinner, thus reducing weight at a low manufacturing cost. Sumitomo Heavy Industry plans to fulfill customer needs as we develop automobile frame applications for staff. One we're working on is developing a variable thickness molding technique that uses pipes of various thickness as the material and, in one step, hot forms and changes the shape of the part along its length. Another application we're developing is a variable strength technique that, like differential quenching used in hot stamping, can regulate the cooling rate of each section to vary the hardness between 980 and 1,500 megapascals. Expect great things from Sumitomo Heavy Industries.